What I'm going to demo today is an issue we ran into like a year ago that we created something for. It's with YesSql indexes or index tables are great, but you have to build them in code, and your content types have to be built in code. And we do a lot of content types that are built in the admin only and never touch code. So how do we build index tables for those content types so we can query on them? So we created this thing called dynamic index tables, and you can create a new one. I'm just going to show from the demo just to hurry things up. But you select the content type you want to index, so you can select all that you want to do, and then you add the table columns you want to index. So you can just add as many as you want. You get different data types like datetime, integer, float. And then you use a mapping script, which uses JavaScript using the script evaluator or whatever. And you basically...
Gint.
What's that?
Gint, maybe. Gint.
Yeah, Gint, yes. You wrote Gint, right?
And YesSql.
Yeah, both of them. Okay. Yeah, so use the Gint. And it basically works the same way that normally a SQL index works. You just return how you want it to be indexed. You can also return an array, just like YesSql, and it'll index each one as its own row. But so for instance, I'm indexing fields, and I don't know if there is that available yet in Orchard Core where you can query fields. I know there was talk a while ago. I don't know if it's in yet.
Yes, there is a feature to project like you are doing all the fields onto a very well-known table with very well-known column types. So it's not as dynamic as what you did, but yes, this is a more generic solution.
Okay, so when I wrote this, that didn't exist. It did in Orchard 1, which it just took a little while to get it into Orchard Core. Yeah, so you can do more than just fields. You can build whatever you want. And this uses the global methods. So if you wanted to query for something inside of this, you could, although not really recommended because your index is going to get messed up eventually. But yeah, so right now I have this built and it's returning that. And if I query, it's going to return this. And then if I added a release date, for instance, date time, and I'll just uncomment this and hit save. And I just rebuild this. And now my index table will include that as well. So that's all I had to demo. Just a quick one.
And that's something we mentioned actually. Well, I did for sure. But I'm not even, maybe Antoine or Dave were there at the meetings where I mentioned something like this. But there are two options, two techniques to design with that, because it's interesting because you use the tables, you use YesSql.
Yes.
But you could also do that for the Lucene. For Lucene, like in Lucene, we have an index, right? We create indexes and we index all the fields, and every field has to say, this is how you index me. But you could do the same thing with a Lucene index to provide a JavaScript to project your objects to an object that will be indexed in Lucene field by field. That would also work. And maybe that you might also want to do that if you want to do a search with Lucene, a full text search, but from projecting properties. So that something I mentioned. And in the case of YesSql, I'm not sure I've mentioned that, but on the YesSql repository, I'm sure we'll discuss that in issues or in PRs or with people involved, that what you did was also an option, that instead of describing statically by code the indices you want to create, we could do it dynamically and then create the tables, but that's a much different level of difficulty that you did. That's great. And then what you implemented is RavenDB. I don't know if you know about RavenDB.
I do not.
And so it's historically it's interesting because the thoughts you had to have to go to this solution. This is something we envisioned also when we started Orchard, even 1, like 15 years ago. When we started Orchard 1, we were looking at databases that we could use. Okay, and the first versions were SQL C because there was no SQLite. It was SQL C, and it only worked on Windows, which were fine. So Orchard 1 was full framework. But we had another option, which was to use RavenDB, which was a very new NoSQL database in .NET, made by the creators of Hibernate, which was still an ORM in .NET and in Java. And so RavenDB is a NoSQL database, which is super popular and is the first .NET NoSQL database, like MongoDB, if you want. Okay? But the issue that which made us not be able to use RavenDB with Orchard 1 is that it was not free, and Orchard was free. So we would have had to force people to use, to pay for a license. So that's why we went with SQL C and SQL Server and others. So we had options with the market. And RavenDB is made in .NET and has the same feature as you, which is you define your documents that you store. So it stores JSON document, okay, like MongoDB. But then you define queries that you name, like you just did, with JavaScript in RavenDB. So an index is defined by a JavaScript script that will return or query, like a link query, but in JavaScript that returns documents. And they process each JSON document. They apply the JavaScript query on it, and they project it to their own store, which at first was Lucene, because they were using Lucene at the store and also for the query engine. But since then, they've re-implemented all their lower level. They don't use Lucene. They have their own kind of Lucene. They have their own storage engine. They have their own everything. But they are doing exactly what you're doing: JavaScript queries and projecting to .NET, to Lucene. To Lucene, you in your case, YesSql. When I created YesSql, I wanted to do exactly the same thing as RavenDB, which is a NoSQL database, but free, but using SQL databases. So it can work anywhere for free. I didn't have to implement my own engine. And it was SQL because people can do SQL queries, which is fast. It scales. SQL is very good, but it's still SQL. And for sure, to do the JavaScript interpretation, they use Gint also. To do their projection also in RavenDB. So you have a micro RavenDB. And what you just did is something I would have loved to, or maybe I will do one day, to be able to do like everything in SQL, but everything dynamic. So you define your objects and your queries in JavaScript. And well, your objects not in JavaScript, but at least your query in JavaScript. And this way, yes, you can query anything with the fastest perf you want. It's all dynamic, but still it's materialized in SQL. So you have all the benefit of SQL query. So you also reproduce the same index processor as we have for Lucene, which is browsing every content item, executing the JavaScript, and then storing in the index. So like I saw when you did rebuild, it's not our rebuild, it's your rebuild. You made the same thing, right?
Yeah, it's my rebuild.
Okay, but the same logic, like to browse every content item one by one and sync. Like, if there is a new one, there is a background task that will reprocess it or process it.
Yeah, it is using handlers, just the normal content handlers, to update new ones, okay. Which isn't ideal, but for the quick and dirty to get this working, okay. That's what we're using.
I see. But so then the handlers will take, during the request, will process every object, which is fine. And then there is a rebuild that can reprocess everything from scratch.
Yes. And that's targeted to the specific content types. I think doesn't Lucene loop through all content types regardless of if they are indexed? and then it just picks when one actually is being indexed, it actually uses it, but it's querying for them all, right?
The index processor, I don't, yeah, probably it's, yeah, because what we do is that we have a table with, well, that was in Node one. I don't remember in Node core, but we used to have a table with all the content items. And then we just process this table, yeah, one by one, and say, is this one indexed, in this one indexed? But it's just a referential. We don't load the document. We just say, we have this document. Is it a good type? Yes. Then load the document, and then process it. So it should be optimized. Okay. So you need to look at RavenDB then and the way they do queries. I don't think they have, for instance, to define the types. You need to because you want to create the tables. They don't have to because we've seen, and they can also discover the types. So ideally, you will not even have to provide the types, right? Just by looking at introspecting the kind of documents that is written, you would be able to find the correct type. But it's easier if you let the user
true.
map the type. Yeah, but at least there is no ambiguity, and they have the type exactly they want, because one type could map to 10 different ones.
Yeah, technically you could do your return early if it wasn't the type you care about. You do it on your script.
Oh, because yeah, the same thing. So you have one, so okay, now you have multiple queries. That's the previous screen. You select which one you want. And then each table could add your UI. The UI you showed us last time was perfect. This one is ugly. I can't. It's hard to navigate. Like I'm lost with the table columns, which are not columns. It's a grid of columns. No, that the misconception. Like that would be great to have these table columns to be displayed in a table.
Oh, I see. Yeah.
With columns. It's stupid, but yeah, just to see what you are mapping to. Because your name, string, length. Yeah, you see, you have 3 fields. Like it's like 3 columns in a table. Name, data type, and a checkbox. And then you have a table with all the fields you want to project to. So you define your table schema. Then you have the map script. Yeah, that's great. Yeah. That's also very close to what we call it's not no-code platforms like Airtable, their Metabase, so Airtable, Metabase, and some others where you dynamically define, like a content management system, your types and how you want to represent them, and then it will create all the tables and fields and everything inside.
Yeah, I had never seen anything like this before, so we thought it was pretty cool. We use it a lot now, and it's worked for us. So
yeah, I'm sure, yeah, it could be part of. It could be a full-fledged core feature.
And I didn't know if it would be something that goes in Orchard Core, if it's just a separate module that people could use as a NuGet package or something, if they're interested.
Yep. Well, but the issue with Orchard Core is that then you have to maintain that, and if it's external, you can't maintain that. So
I do have to un-Newtonsoft it though. Yeah, we're moving to Orchard Core 2.0 right now, so I'm having the fun of getting rid of Newtonsoft there.
Why do you use it there? Why do you need it?
What's
Let
that?
me see, because okay, your result, the JavaScript result is not Newtonsoft. This is a pure .NET object, well, the JavaScript, the Gint object. So you then to apply the mapping, and then why do you need to do JSON here? I don't understand.
It's when you're passing in the content item into this script evaluator.
I see. You will have all the issues that George has been working on, because here your content item your .casebar.intake.date.value. This is a dynamic value, and then Gint has to understand that it's, for instance, I don't know, string, and then store it as your JavaScript string. So yeah, there will be Gint issues, Newtonsoft issues, but yeah, you need to wait for George's fixes, or maybe everything is in there. Oh no, I saw one. that PR that George made to support JSON dynamic value and automatic conversions like this. Might be an issue. Well, it's fixed, but it could be a temporary issue. Yeah. No, that's great. That one, let me see. So you create tables. At what point do you create a table?
It gets created on first save, and then if you change it, I think I just drop the table and recreate the table.
Yeah, because SQLite doesn't support adding proper. Oh, yeah, not just SQLite. Like some database, you can't even change the type of the column. So if you change the type here, you can't say update column. You have to recreate everything. And because it's an index, you can say that's fine. We do the same thing with routine, like just drop and reprocess everything to repopulate the index. It's just an append-only index, so that is fine. There is no data loss. I mean, there is no data loss. Users don't edit the value. There is nothing to lose from the user. It's just projection, like materialized view. So you just recreate the view. So that's fine. So you create it. Yeah, you have to delete it and recreate it. Every change.
Yep.
But it's rare, so that's fine. Well, and also you could say that your add column here can just be deferred. So it's just when you say save, you're like, okay, all the changes to the columns have been made. Let's recreate the whole thing.
Yeah.
So you use SQL Direct also?
I don't really remember what all I'm using, to be honest.
Because it has to work with every database. So the generating.
Oh, yes. I did only make this work with SQL Server because that's all we ever use.
Okay.
So yeah, it would take a little work, but yeah, I think I'm at the Dapper level and I'm just creating the tables or whatever, removing the tables.
Yeah, so you could build an independent tool, do like Zipka did with the workflow, and you create a NoSQL solution. But there are lots of open source solutions like this today, where you would design dynamically your types, where you will design your projections, design your queries, like we have the queries module in YesSql, and then expose it as APIs, and then it's like a completely dynamic data manipulation.
That's an idea.
With APIs and GraphQL, but this is what YesSql is, so that here you're just missing the JavaScript projection. Yeah, I'm sure Antoine will remember that we mentioned that multiple times, being able, or maybe if not Antoine, at least Jasmine, because we mentioned that, like instead of having these kind of queries, at least for Lucene indexes. I'm sure we have an issue with that to provide a Lucene index with a JavaScript query instead of just indexing all the fields. So you can index whatever computed value you want, not just the field itself. Yeah. Good, that's great. I like it. I'm sure others will. Cool. Thank you.